The Aneurysms project brings to medical professionals across Europe new measures of disease and optimized access to clinical data, supporting their decisions in the treatment of cerebral aneurysm.
Aneurysms set out to show how clinical practice can be transformed by a new workflow approach to diagnosis and treatment that includes freshly developed knowledge discovery and simulation techniques.
The integrative approach of this Aneurysms project allows us, for example, to better estimate the rupture risk of aneurysm, something that is otherwise very difficult to understand.
Let's take a look at this medical condition.
Arteries may get a weakness in the vessel wall. At this point, the artery will blow up like a small balloon. They also occur at the base of the brain, so we are calling them intracranial aneurysms.
If we discover an aneurysm, there is need to understand if, when and how we will treat this aneurysm. So computational information that helps us to do this is of great value to share our responsibility in taking this decision.
Aneurysms tackled the issues affecting optimized care by re-examining the 5 key concepts affecting decision-making. The first concept is patient information from the clinical record.
Aneurysms took a radical look on how data collection can be optimized, and we developed a standardized system for use in hospitals. Medical research usually needs great numbers of cases, and we therefore built a system that connects different hospitals in Europe together. This is a secure system creating a giant database, and other hospitals can easily join the system. We use a method called semantic mediation federation.
And with data federation, effective, secure communications are crucial.
The Aneurysms architecture has been built up using standard web services and newly developed web services to achieve that security. What we do is combine the access to data repositories and remote computing resources linked into the clinical centres. And those remote computing resources provide much higher processing power to the clinics.
Using secure grid technologies, we're also able to allow authorized researchers to work on the entire collection of anonymized patient data that has been amassed across all centres.
The second clinical area for investigation by Aneurysms is genetic susceptibility.
First, we performed a whole genome association study and pooled our data internationally, and were able to identify 6 loci associated with the disease. Therefore, we may be able to identify patients at risk of having an aneurysm using genetics. We looked at gene expression in blood and were able to analyze and identify markers for rupture. In the near future, we should be able to identify patients at risk of rupturing an aneurysm only by blood.
The third area tackled by Aneurysms is diagnostic accuracy. And here, Aneurysms has developed sophisticated new measures using computational models.
We've put a lot of effort into development of software to take a medical image of an aneurysm and to recreate it in the computer.
We have a new way of identifying and extracting the arteries, which is called segmentation, and that is customized for intracranial scans, and it works well.
To characterize the aneurysm, we transform the segmented arterial tree into three-dimensional computer model, and then we subject this to a realistic computer-simulated blood flow.
With the simulation bringing fresh insights into diagnosis, the fourth area where Aneurysms got to work is in treatment planning.
For each patient, the clinician needs to decide whether to intervene or not. We can simulate this in great detail, allowing to take a decision before the treatment.
The final area where Aneurysm has developed tools is in the generation of knowledge from raw information.
Medical knowledge is advancing daily. We have built a new system that enables the people to search in this new information daily, and so in this way we are able to convert information which is in public available databases directly to aneurysm treatment knowledge. For the aneurysm domain, we started building the definitive ontology, that's the aneurysm ontology. The major tool that has been developed is an advanced search engine that allows us to identify recently published works on genetics.
We've seen the 5 areas where Aneurysm has proposed significant changes to clinical practice. Bringing these changes together, the project also includes a risk management module that analyzes each treatment option. Importantly, it includes the no treatment choice, the key to possible significant cost reductions.
So, we've seen that Aneurysm has examined and augmented the entire diagnostic and treatment process, and what has emerged is a complete new paradigm for patient care. We are working closely with the European Society for Minimally Invasive Neurological Treatment and hope to bring this work into widespread use in aneurysm care, and also to extend the concept to other medical conditions.
In the Aneurysm project, over 250 people came together from all over Europe to unite clinicians and researchers and to develop a better way of managing disease. With the project's work now continuing under the care of ESMINT, we hope we have succeeded.